Hi, I'm Doug Smith. This summer I attended the IEEE EMC Symposium in Detroit, the ESD Symposium in Tucson, Arizona, and PCB West here in Santa Clara. I'd like to show you some of the video I took during those symposia, generally from the exhibits hall, of products I thought that were interesting or different than the rest, and so as well as some of the show scenes from setup and so forth. So we'll start off with the IEEE EMC Symposium and probably do 2 or 3 videos in this to keep it down to 5 or 10 minutes at length. So we're going to start off with some things here I have on my desktop over here. We're going to look at some setup stuff that they did at the beginning. Then we'll look at a very interesting USB comb generator, as well as some interesting components for use on a circuit board. So let's get going. And today there's all kinds of tutorials. That's why everyone's walking around. People are attending these tutorials. To me, meeting the people at these places is probably the most important thing, even more important than the presentation, to find out what's been going on. It'll be more crowded later today when people start arriving. And here we are as we're setting up the exhibit area and the Agilent booth. Things still getting unpacked here. Let's do a 360. Pretty big hall.
Home.
It's going to take a while to discover where the chocolate is in here tomorrow morning when they open. I always do my chocolate scan first and then on to the technical stuff. And back to the Agilent booth. Okay, here we're at the AET booth and I found a very interesting little product. And let's see, I forgot your name here. David Guzman is holding it in his hand. And let me put on the little macro lens here. And that little gadget, there's one down here on the table, is a USB comb generator. And here's the spectrum display out to 4 gigahertz on it. And let's go up and get our macro lens there. And notice the first gigahertz up here is pretty flat. Looks like it would be very good for doing seminars, not to mention EMC testing.
Yeah, there's about 7 spigots in the first gigahertz.
Okay, and you can get it at a 10 megahertz separation as well.
Yeah,
which
10
is what I
megahertz
would
separation,
do.
However, has a little bit less power.
Okay.
Because the spectrum is spread out at less peak output.
Right.
But still very good, very useful.
Okay. Wow, that's very good. And let me go back up here and get that AET Applied Electromagnetic. Where are you based out of? We're
North Carolina.
North Carolina, okay.
Well, it says Maryland.
What's your website? Is that it there?
The website, no, this is my business. The website is...
Oh, appliedemtech.com. Okay, thank you. So I'm here at the X2Y booth, and I'm talking to Steve Weir. There he is, intently adjusting something on his PC. And he's going to describe to me what he's doing. He's got some interesting looking stuff down here, and he's going to describe what he's doing.
Hi, Doug. What we've got here is we have a basic cooking show test. We have 2 boards that are both running identical FPGA code, and they're just exercising a whole bunch of IOs here, 360 on each board, and we're monitoring the noise on the VCC IO cavities for each one of the boards. The board on the left is using X2I capacitors. There's 16 of them.
Where are they in the board?
They're right here.
Let me see if I can zoom in here. We got a little macro lens here.
We have positions for X2Ys alternating with positions for 402 capacitors.
Okay.
And this power cavity is basically a rectangle about this size in the board.
Okay. And over here, these are just regular capacitors.
And here we've populated the 402s and the X2Y positions are open.
Okay.
And they're both running identical code. We happen to be synced up on with the scope on the X2Y side, so you can see the pseudo-random sequence that we're driving out. and we're on the same scales here for monitoring our power rails. You can see the peak-to-peak noise that we have with the X2Y superimposed on the peak-to-peak that we have with the 0402s.
That's about 4 to 1.
And the 0402s are each using 4 vias per capacitor, and the vias are as tight in as you can possibly get.
No one ever does that.
Well,
or very VV.
Yeah, it can be a real nightmare and breakout because you're close into the chip, and you're drilling all these extra holes where you want to get signal routes out away from the chip. So it is unusual to see 4 vias per cap, but it does get done someplace. So there's this tremendous...
Let me get a good shot of that. Let me put on the little macro lens here and see if we can get in. So the reddish is the
regular.
Is the envelope of the regular, and the X2Y
is in cyan.
Wow, that's amazing.
Right, and yeah, it's a huge difference, and they're both running identical code. And you know, if you want to make I'll have to turn the persistence off here, but we go to variable persistence. So if we turn, you know, as we light this thing up, you can see the noise just comes up proportionally to how many IOs are firing away, and we can do the same thing with the X2Y. If you turn off IOs, you get less noise. So it is linear and proportional.
And these are moving because they're not. Are they synced together, or they're separate?
They're not synced together.
Okay.
So
when you sync to yours, the others are sort of moving around.
Right. So
but you can see they're way bigger.
Right. So for example, if I just turn the trigger off.
What's the scale there on voltage?
You're 50 millivolts per division. Okay, you can see that down here for the 2 channels. So you've got 100. So this guy's blasting. All of his outputs are going full bore. And 16 capacitors for 180 outputs going here.
Right.
So there's basically, if you think about common rules of thumb that are out there that have worked, typically you would try and put down a capacitor in a 402 for about 4 IOs on a Thevenin termination. And what we've got here is 16 X2Ys against 180 outputs. So we have basically about a 17 to 1 ratio on capacitors, and our peak to peak is 100 millivolts.
Wow. And the peak to peak on the other is what? Hundreds of millivolts,
yes,
many hundreds of millivolts.
350 millivolts or something with the 0402. So clearly what we'd want with the 0402s is about 65 capacitors.
That's
which
impressive.
Would pretty much fill up this entire column.
Wow, that's a great demonstration.
Yeah, thank you.
Thank you, Steve.
My pleasure.
Well, that's our first installment from the IEEE EMC Symposium in Detroit, and I'll have another one out possibly later in the week. Thanks for listening. Hope you enjoyed it.